Okay, so number 5 is, believe it or not, a question about the derivative. And it's about one-dimensional motion. So it says a particle moves in space, so this is one-dimensional space. What does one-dimensional space look like? It just looks like a line. It could be a horizontal line or a vertical line. You can imagine that there's a particle, and t is time, and so the particle is moving around. It likes to go over here, and then I'm sorry, that must be extremely loud when I cough into the microphone. I should have gotten some water. But the particle is moving around, it's going left, it's going right, and what happens is that this equation in terms of t is what tells you where the particle is at time t. You can imagine that there's some zero here, some fixed zero. And yeah, so this equation will not cause the particle to move like that. So just to satisfy your curiosity, I tried to make a decent picture, and I did. Okay, so I don't think I have to be too humble about this picture because Foo-Platt made it. This is a graph of t minus 1 divided by the square root of t. And it looks like that. So maybe we could visualize what is happening here. Oh, actually, I lied. What I had done here is a fairly decent depiction of what the particle does. So at first, you know, when right off the bat, whoops, man, I'm sorry. I wish I had control of my body. So when t is equal to 0, when it first comes out of the starting gate, it's at negative infinity. So, oh God, it's really not my fault. Somehow it's not my fault. When it first comes out of the starting gate, now I need my picture again. God, it's maximized itself. When time begins at 0, and you go a little bit to the right, then the particle kind of starts out at negative infinity somehow. Don't ask me how. And then before too long, it's covered the infinite amount of distance from negative infinity to 0. And so right here, after 1 second, it's at 0. And now, after it's at 0, you can see that it continues to move in a positive direction, and it's kind of maybe not going as fast as it used to. Haha, just like the rest of us. But it keeps moving more and more in the positive direction as time goes on. So it kind of somehow comes like a bat out of hell, like infinitely fast from the left-hand side, and then kind of starts to slow down and act more normally as time goes on. That has absolutely nothing to do with the question. So the question says, basically, what is the derivative? What is the velocity? So when you have something that describes movement in space, remember S stands for spatium. S prime of t, the same thing as, now I'm just going to try to play with the Leibniz notation, same thing as ds dt. That is what we call velocity. And it's literally the definition of velocity, I guess. And now this says, what is the velocity when 9? So that's either, we could argue about whether that is grammatically correct or not because the variable is time. But yeah, I made a typo. So this should say when t equals 9. And so what we want to find, the answer to this question is going to be v of 9. So the first thing we have to do is find s prime, then plug 9 in. It's the same thing as s prime of 9. Okay. Alright, so you're thinking, good lord, we don't know how to take the derivative of this thing. It's got the fraction and the radical, and surely you're not serious. But we will later learn how to take the derivative of complicated things like that without breaking them apart first. But the reason that we can do this one is because you can split that up. This is the same thing as t over the square root of t minus 1 over the square root of t. Okay, and both of these, so we can take the derivative of these separately. Why is that? Let me go a little step further. The same thing is t over t to the 1/2 minus 1 over t to the 1/2. So this is a little bit of practice with exponential notation. So you can think, oh my god, you're being so cruel, or am I? Because the course will be not just my course. Like, I like to justify these things by thinking that you'll get a really hard professor for calculus 2. And where will you be then if you don't know how to work with exponents? So what this means is, so take the bottom exponent away from the top exponent. So the top exponent is secretly 1. So then you get t, 1 minus 1/2 is 1/2. And what have you got here? You can think of this as t to the 0. 0 minus 1/2 is negative 1/2. So minus t to the minus 1/2. Okay. Alright. Super fantastic. This is just the original function. So what happens when we take the derivative? You can just use the power rule in each place. So s prime of t is 1/2 comes down. Take 1 away from 1/2 is minus 1/2. And now the minus 1/2 comes down, but there's already a negative. So two negatives make a positive. 1/2 t. And now this is a little tricky. What happens if you take 1 away from negative 1/2? Pause the video and figure it out. You get minus 3/2. And seriously, not everybody knows how to do that. And so that it doesn't trip you up, you should pause the video. Alright, so now we have to plug in 9. Okay, so what is s prime of 9? Okay, is that what I said? Yeah, I said when 9, yes. So this is 1/2 times 9 to the minus 1/2 plus 1/2 times 9 to the minus 3/2. So now there are several ways to do this, and so I get 2 ways anyway. You could go back to the radicals. So this is the same thing as 1/2 times, same thing as 1 over the square root of 9. So that's probably the simplest way to do it. Let's do it like that. Now here, I have to do something which never fails to please my students. I'm going to do this mathematical operation. I'm going to think of negative 3/2. Think of that as negative 3 times 1/2. Okay, so imagine that I have 9 to the minus 3 times 1/2, like right here in this situation. Then you can take out the negative 3 like this. This is the same thing as 9 to the 1/2 to the power negative 3. Okay, same thing. So that's just a legal move. And if you want to talk about why that's true, I could probably come up with an explanation if you don't ask me too early in the morning. And negative 3 up here. Okay, and the reason that's good is because 1/2 means square root, and 9 has a nice square root. So now I've got 1/2 times, the square root of 9 is 3, so times 1/3, plus 1/2 times the square root of 9 is 3. So we've got 3 cubed here. Okay, so it's like this. And I guess you can leave it like this. In fact, I wouldn't get too upset if you just left it the way it was here. But this is fine. If you go on, I actually did figure out what this is. It turns out to be 29 over 156, and that might be a delightful exercise in writing and adding fractions. Okay, this problem is over.